Kia ora. Here's our fifth example. So you should know by now, go for the molecular ion that's as far up at the highest peaks, and you'll see very clearly this 1-to-1 ratio, 2 units apart, with little carbon-13 isotopic peaks there, and otherwise that is a clear indication of bromine. The bromine peaks are a little bit sort of here, actually further down, so we can't really see it over there. That could be a carbon attached to a bromine. So that is for a bromine. We know there's no nitrogen, again, because it's an even molecular ion, so we don't have odd number of nitrogens present. And we know it's not chlorine because that ratio is not 3:1, as you would expect for chlorine. Further support of no nitrogen, we have no peaks around about 3,500. That's just a little anomaly. And yes, you could argue that could be a nitrogen, but it's sort of clear that we don't have a nitrogen from the molecular ion. So again, alkyl is matched up. We have some alkyl peaks, carbon, methyls, and so on. We know clearly there are no double bonds in terms of carbon-carbon double bond, but we do have a carbon-oxygen double bond here in the carbonyl. We know that it is not a carboxylic acid because we don't have that broad triangular absorption band for the OH. We know that this is too low for a acyl chloride and it's too high for an amide, because remember, amides are around about 1650 and acyl chlorides are around about 1800. So this peak over here we know is from a carbonyl, but it's too downfield for a carboxylic acid, an ester, an acyl chloride, and amide, which all are around about this area. And it is in the right area for an aldehyde or ketone. Now, you could try and look for the aldehyde over here. That could be part of the W. So that is a possibility. So going towards the formula, molecular ion of 150, subtract the large mass from the bromine, also the oxygen from the carbonyl, and that leaves us with 55 from carbon and hydrogen. Divide by the molar mass. If I've got 4 carbon atoms, which looks right because I have 4 carbon environments, so I must have at least 4 carbon atoms present. And therefore I have 7 hydrogens if I subtract 48 from 55, giving me a formula of C4H7OBr. So Br counts like a hydrogen, so it's in the range of CnH2n, which does match an unsaturation of 1 double bond, which we can see is from the carbonyl. Kia ora.